This is another mini lecture for Module 6 on hypothesis testing. One topic that's covered in the textbook a little bit, and there's also a supplemental reading on, is the idea of one-tailed versus two-tailed test, also referred to as one-sided or two-sided tests. And make sure that you also read the Whitlock and Schluter reading. In the first chapter of the textbook, it talks about that statistics is a changing field, and this is an example. I won't quiz you on calculating one-tailed tests, but it is important that you understand why there's a little bit of debate on this issue. And we're going to go through an example. Here I just have a heading here with one-tailed and two-tailed tests, and when we have a two-tailed test, our null hypothesis is that the means of the populations are equal, and our alternative hypothesis is that they are not equal. I've come up with a sample t-statistic calculation, which is 1.856, and our sample size here is 25. Our decision rule is going to be based on an alpha of 0.05, and then we need to calculate our critical value. Our critical value with, so it's a t-statistic with an alpha of 0.05 and 24 degrees of freedom. For a two-tailed test, so alpha of 0.05 and 24 degrees of freedom gives us a value of 2.064. So this value is 2.064. Then we can look at the t-distribution for a two-tailed test and add on our critical value. So this is t-crit. And then again on the negative side, because this is a two-tailed test where if we rejected our null hypothesis that they will be unequal, and mu1 could be either greater or less than mu0. So here we have our critical values, and then we want to look at where our t-statistic falls relative to these. Now keep in mind, when it's a two-tailed test, that these two areas, because our alpha is 0.05, each represent 2.5% of the data. And they're distributed across the two tails. And our t-statistic is 1.856. So this is our t-statistic of 1.856. And it does not fall into the tails. Therefore, we're going to retain our null hypothesis. So in this case, 1.856, we're working on the positive side, is less than 2.064. That's why I don't have it in absolute values. Therefore, we're going to retain our null hypothesis and conclude that there is not a difference between those means. Now, if we look at a one-tailed test, here we have our null hypothesis, and now it has some directionality to it. So it's saying mu1 is less than or equal to mu0, and our alternative is that mu1 is greater than mu0. People use one-tailed tests often when they're only interested in one direction, and the controversy a little bit is because people are then doing a little bit of bet hedging, that there's a higher probability of rejecting your null hypothesis in this case. And I'm going to show you how this works. So now we have the exact same t-statistic as we had in the two-tailed example. Our sample sizes are the same. They're both 25. And now we need to calculate our critical value that's one-tailed. So the alpha is still 0.05. Here I've written, so this is our alpha value. It's a one-tailed test now, and we still have 24 degrees of freedom. So when we look now at the table, we're looking at the one-tailed test for our critical t-value, 0.05. Notice that this is the same as 0.1 for the two-tailed test. So 0.05 with 24 degrees of freedom gives us a critical value of 1.711. So our critical value is now 1.711. Now that it's a one-tailed test, and we're only interested in if it's mu1 is greater than mu0, we're only interested in the positive side. So we only have one critical value, right? We don't also have one on the negative because we're doing a one-tailed test now. It's 1.711. And our t-statistic is the same as it was up above, but now our t-statistic is going to fall outside. So it's 1.856. And now it falls within this region. And the reason why it falls out here now, and it did not up here, is because when it's a one-tail test, all that 5% is put into that one tail. And in this case, because our value of 1.856 is greater than 1.711, so our t-statistic is found out in the tails. Therefore, we're going to reject our null hypothesis and say that the value for mu1 is greater than for mu2. And the controversy here is because some people think that this is sort of like cheating, because it might be possible for these values to be found in the other tail. And therefore, they always suggest that using a two-tailed test whenever the data has the possibility of falling into either tail. Again, read the pages from the Whitlock and Schluter text that have been posted online for more information.